Alright guys, I wanted to run through these with you real quick, as I said I would. So number one, let that be x1, y1. Bear with me, cursor died here. Come on, there we go. x1, y1, x2, y2, and then we start plugging in. So then we're going to subtract the x's, so it'll be negative 3 minus 2. And then we'll have 5 minus 3. Okay. Order of operations says I have to do these differences first. So negative 3 minus 2 is negative 5. And then 5 minus 3 is obviously 2. Order of operations says now we got to square those. So negative 5 squared is 25. 2 squared is 4. So it's going to give me radical 29. Okay. 29 is prime, so that thing does not simplify any further than that. And we are good to go. That's the first one. The second one over here, same principle. x1, y1, x2, y2. Okay. So we're going to go x2 being 5 minus x1, which is negative 11, plus then y2, which is negative 2, minus y1, which is 3. So it's going to give me, so when I square this, square it, 5 minus negative 11, when I do that, that's addition now. So it'd be 16 squared, plus then now this will be negative 5 squared. So this is going to give me, so 16 squared is 256. Negative 5 squared is 25. Okay, so that's going to give me root 281. 281 is a prime number actually. Okay, so that does not simplify either. Okay, so first two give me prime numbers and they do not simplify any further than that. If I go to number 3, kind of maybe speed the process up here a little bit because one of these values has a 0 in it, so it's nice. But when I maybe let that be x1, y1. Again, you can do this on each one of these. Hopefully you guys find some routine here and find out some of the stuff you can do a little bit quicker than just plugging straight into this form. You can do the subtraction in your head maybe, but to keep it straightforward for everybody, we'll get something like that. So 3 minus 5 then becomes negative 2, and then this becomes negative 8. Again, depending on the order that you subtract them, you might get positive 2, you might get positive 8, but that does not matter because when I square both negative 2, positive 2 give me 4, positive 8 or negative 8 squared would give me 64. So it gives me root 68. Okay. Now root 68, that one does simplify. Okay. If I go to radical 68, that is radical 2 times radical 34. That is radical 2 times radical 17. So these two things here, radical 2 times radical 2, just gives me 2. And then this radical 17 is by itself underneath the radical. Okay? We could do it this way. We could say that radical 68 is the same thing as radical 4 times radical 17. 4 times 17 gives me 68. And then the square root of 4 is then that too. Okay? So, we were looking at 2 root 17 as the answer there. This one here is a little bit harder because of the fractions. We need common denominators and all that kind of stuff. So take my x's and subtract them. So I'm going to have 2/3 minus negative 8/3. Then I'm going to take my y's and subtract those. So I have 7/4 minus 1/4. When I do this, I'm going to get, 10/3 here squared. Plus this gives me 6/4 squared. Just because it's going to make things easier later on, simplify that 6/4 first. Make that 3/2. Now we got to go through and do the simplification. So whenever I have a fraction squared, remember that means 10/3 times 10/3. Well, 10 times 10 is 10 squared. 3 times 3 is 3 squared. So this here gets me to that. So whenever I want to square a fraction, I square the top, I square the bottom. So 100 over 9. And then this one over here gives me 9 over 4. Okay. Now in this case, I need a common denominator. This 9 and that 4 cannot add together. So I need a common denominator, and that common denominator is found by multiplying those two things together. So it becomes 36. So I'm going to rewrite both these fractions with the denominator of 36. And now I got to talk about how do I get this 9 to turn into 36? Well, I multiplied it by 4. So I need to multiply the top by 4. Which gives me 400. And I really just multiplied by 1. 4 over 4 is just 1. Here I need to multiply by 9 over 9. And that will give me 81/36. Just to show you, how does that make sense, or why does that make sense if I were to grab my calculator. Okay, 100 ninths gives me that value there. 436s should give me the same thing. Okay, same kind of thing happens with 9/4 and 81/36. And that is all still underneath my radical. Now that I have a common denominator, I can add those together. So I get 481/36. That's a 1 right there. We talked in class how we can break that up. This is all law of exponents, why I can do this. 481 is 37 times 13, so there's no perfect squares that divide 481. But 36 is a perfect square. So I can rewrite this answer that way. Radical 481 over messed it up. Square root of 36 is 6. So I can rewrite it radical 481 over 6. And now the number 5 we talked about, we can do this using the distance formula. If I were to graph this thing, -7 5 might be right there. 4, 5 might be right there. That is a horizontal line because they both have the same y value. So if I got a horizontal line, and this is at -7/9, and this one here is at 4, if you remember, all I have to do is the absolute value of a minus b. If that's a, and that's b. So I'm going to take -7/9 minus 4, absolute value of that, gives me 4 and 7/9 as a mixed number. So 4 and 7/9. It's not really nice as a mixed number. We like to change that. Multiply the 4 times 9, get 36. Add my 7 gives me 43. And then 43 over 9. That's the best distance for us. If you let us 47/9 right now, I don't really mind that. That's fine. This question here is the same as the first 5, but instead of giving you the ordered pairs explicitly, I made you work for them a little bit. So you have to find -6, 4, and this one here is -0. -6. So then distance here, subtract your x's. -6 minus 0 is -6. Subtract your y's. 4, and this is where people get into problems. 4 minus -6. 4 minus -6 turns into 10. So we'll square that. So it gives me root 136. This is 36, and this is 100. Add those together, I get 136. 136 is going to break down to 4 is the largest perfect square that divides 136. So I get 4 and then radical 34. Okay, if I multiply those together, I get 136. But radical 4 is equal to 2. So this thing breaks down to 2 radical 34. 34 is still a composite number. It's 2 times 17. But both of those are prime, so there's no perfect square inside that 34. So that's why we leave it as that final solution. And the last one. Okay, the last one, the idea here is that they are giving us a lot of information here for our distance formula. But it's not that we're asked for distance here. Here we're asking us to find ordered pairs, but we use the distance formula to do that. They tell us initially that 80 is your distance, so 80 is D. They tell us A is that point there, so that's maybe X1 and Y1. They tell us that B is on the Y-axis. So B is some point on the Y-axis. Now I don't know which one of these points it is, that's what we're trying to find out. But I do know wherever that point B goes, the X value should be 0. I'm uncertain about the Y value. Okay, so when they give me X1 and Y1 explicitly here, X2 and Y2, X2 is given explicitly, or I guess it's implicitly provided, but it is a concrete value. Y2, that's what we're looking for. We don't know what it is. So now we've got 1 variable, 2 variables, 3 variables, 4 variables, and here's the 5th variable, but it's unknown. We should be able to solve for that. So plugging stuff into this formula over here. Distance is root 80. Okay, I said x sub 2, we let that be 0, minus then x sub 1, which was negative 4. Square that. Plus then, now y sub 2. Y sub 2 is that y. I don't know what it is. Minus then y sub 1, which is 2. Okay? If these are both sides are underneath a radical, and if they're going to equate, then what is underneath this radical has to be equivalent to what is underneath this second radical. So we can get rid of the radicals that way. If you're a person that says, I like to square both sides, that effectively does the same thing. This turns into 80. This becomes positive 4 squared, which is 16, plus then y minus 2 squared. Bring this work over here. We're going to try to isolate the y minus 2 squared. We need to get to that variable. So we'll subtract 16 from both sides. And I get that. Okay, now here's my argument. Y minus 2 is just representing a number. When y is a variable, represents a number, remove 2 from it, it's still just a number. Okay, so it's similar to, y. Y is just a number, or maybe some other variable z. Z is just a number. If I wanted to solve for z in this equation, I would take the square root. Well, if that just represents a number, then this just represents a number, remove 2, which is just another number. So why can't I just do the same thing? Square root that, square root that. The right-hand side is going to leave me y minus 2. The left-hand side, we got to be careful. Square root of 64 is 8. But remember, the square root of 64 is a symbol for some number that multiplied by itself gives me 64. Well, 8 times 8 gives me 64, so that's fine. But negative 8 times negative 8 also gives me 64, so I need to have both those. And what that gives me then is 8 equals y minus 2, or negative 8 equals y minus 2. Solving this one will give me y to be 10. Solving this one gives me y to be negative 6. So I've got 2 points here. Okay? Kind of go to GeoGebra here to show this. If I... the first point that we came up with that they gave us was negative 2, 4. So A was located... Actually, I think it's negative 4, 2. My apologies. Negative 4, 2. And then they said point B was located somewhere on the y-axis. We see that if B is on the y-axis, you see that that 0 right there is always 0, no matter where it goes. The distance here has to be square root of 80. So square root of 80, I think it becomes like 8.49 or something. 8.94, okay? If I ask for that distance right there, it's 5.25 right now where B is. So obviously that location, 0, 6, is not the ordered pair I'm looking for. I want to move this point B until that number right there turns into radical 80. Radical 80, like I said, was 8.94 as a decimal. So there we go, turned into 8.94, that's radical 80. I think I can actually get this thing to actually write down AB's length this way as a radical. So radical 80 simplified is 4 radical 5. So that's this 8.94. So you see at that point is happening at 0, 10. Well, 10 was that 1y value that we found right here. Okay, but there's nothing that says that we cannot. Nothing said we had to go vertical. Had to go up. Because if I'm here, if B is down here, we can still stretch A to B to be 8.94 there, and you see again 4 radical 5 or radical 80 as that length, and that negative 6, 0, negative 6 there, that negative 6 was found inside our algebra again right here. So we have 2 order pairs that could be potential points for B. It could be 0, 10 or 0, negative 6. Hopefully that helped. We're going to use, like I said in class, we're going to use this stuff a lot. So the sooner that we can kind of get a grasp for it and hang for doing this problem, this type of problem, the better we're going to set ourselves up for other sections.